Alright, hello class. My apologies for not being there. I actually did make a pretty good effort, but there was not any way I could have driven to work today, and I apologize for that. However, I just wanted to make a quick little video for you guys that kind of outlines some of the big ideas from lesson 31 so that you can have a little bit of support going into that. And just as a reminder, it's not going to be due till next week, so I know a lot of you are still catching up on lessons from previous weeks or weeks for some of us, and so that should take a priority over this. But the big idea or the big goal of this lesson is really to use all this trigonometry that we've been working with to try to find the area of given figures. So basically using trigonometry to determine area is kind of our big goal. Okay, so this is kind of straightforward, and a lot of you this should be a review for, but if I'm given this first triangle, and I can definitely find the area of that triangle, because that's what the question that you'll start on this lesson 31 is, can you find the area of the given triangle? And in this case we certainly can, because we know the base and the height. So we could do base times height, or 5 times 12, which is 60, but I know that's half of the corresponding rectangle. So this first one, triangle ABC, would have an area equal to 30 units. Okay? And that's pretty straightforward, I think. So then we could think, let me just shrink this up. So we could move on to this next one. So if I'm still thinking about the same idea, and I'm going to say, well, what about this guy? Can we find the area of that? Well, we certainly can, right? Because if we're looking at this, we know the base and the height. So we have a base of 20, height of 8. We can think about if I want to use kind of the formula and put it in. So I know half the base, so half of 20. And then in this case, I'm going to have to also multiply by the height. So the area of this triangle would equal 1/2 the base. Half of 20 is 10. And then I know that 10 times 8, the height. So that's going to give me 80. So we know that this triangle DEF, and I'll write it below, triangle DEF is going to have an area of 80 in this second example. So I can certainly, and I'll just put a blue star, yes I can, yes I can. However, when I look at this third example, all I'm given is this side length here, and technically the base, but I do not know the height of that triangle. So that height is not given. I mean, I could add a line there and know that these form right angles. However, without knowing either of the other angle measurements, I don't know any angles, and in this case, I don't think there's any way to determine the area based off the information that's provided. So in this case, I'm going to just put a little red star next to this one, and I know that that's not possible. So I do not think it's possible to determine the area given the information in this example. Okay? So this is meant to kind of be a review, but really to kind of force you guys to think about what information must be given in order to determine the area, and how can we use trig to get there. So I'm going to jump over to another problem, which is a little more involved. So kind of here's your next problem. So this is coming directly from your lesson. And when you're looking at this next example, we're given some information. So we're given all three sides. So knowing all three sides, I think it is possible. So I'm going to start by saying yes, possible. Because I know that it is possible for me to determine the area of this triangle given the supplied information. So I need to think about adding a line, however, because if I want to figure out the area, I need to know the height, and I'm just going to call this, y for the height of this triangle. So in order to figure out and be able to use my formula, area equals 1/2 the base times the height, that's the area formula for a triangle, I need to really figure out what the height is. So, and this is kind of maybe the stretch for some of us that might present a little bit of a challenge, is that I don't know what the individual parts of the base are. So for example, if I were to add a point here, I don't know what this piece is, x, but I do know that the whole base is 15. So I'm going to kind of use variables and chunk this up, and I'm going to express the base in two parts, one part being x, and that's this segment right here, and the other part being 15 minus x. Because by knowing that the whole length of the base is 15, I know that I can express this using kind of these unknowns, x and 15 minus x, as the two parts which make up the whole base. So knowing that, I can now really try to use the Pythagorean theorem. So I'm going to use the Pythagorean theorem in two ways. So I'm going to first start out by trying to figure out this height of my triangle. So I'm talking about this height right here. So I'm going to try to figure that out by knowing that the hypotenuse of GH is 7. So I'm going to do 7 squared, which is the hypotenuse, and I'm going to subtract that from x squared, which is this leg, which represents G, and maybe I'll add a point to this. I'm going to call that point J. So this represents GJX, and I know that has to equal the height squared. So my height, again, is, if I want to maybe go ahead and erase and just think about, it's not going to let me do it. So the height is really the height of the triangle. So if I continue with that, that is going to give me, so that's going to give me my, that equation would work to figure out the height. But I still have two variables in that equation, which is problematic. So if I look at the other side, I can write another equation that represents the height given the other right triangle, so the other side. So that would be 12 squared minus, and then I'm going to put 15 minus x, which is all being squared. And so that is then going to be equal to h squared as well, because that also has to be equal to h squared, which is the height of the triangle. So again, all I did was just put in 15 minus x squared, and then that 12 came right from 12 squared. So those two pieces are really just applying the Pythagorean theorem. But now if you'll notice, I have two equations in here, but they're both set equal to h squared. So if they both equal h squared, then I can set them equal to each other, which is a strategy I know you guys learned in algebra. So I'm just going to show this, and I'm going to rewrite it below. So if I have 7 squared minus x squared, and that equals 12 squared minus 15 minus x squared. So now I have a pretty solvable equation. So I can try, let's see if I can drag this up. So I'm just going to work this up a little bit, just because I'm running out of space. So I can simplify a lot of this. 7 squared is 49 minus x squared, which equals 12 squared is 144. Okay, and then I can really distribute. So if I want to distribute the negative, I could do that first, which is going to leave me with negative 15. I should apply the exponent, so it's actually, sorry. So if I squared both parts within this, is going to actually be 225, because 15 squared is 225. And then I need to square x, so I still have x squared. But since that was a negative outside the parentheses and inside, this is going to become, hold on. Okay, sorry about that. So I was starting to oversimplify this, and I realized I should probably show the factoring. So again, remember when I have to square 15 minus x, that really takes you back to your idea of factoring in algebra, and I could go through all of this, but for time's sake, and I just want to make sure the 15 and the 15 is going to be 225. You know you're going to have 15 times negative x, 15 times negative x. If we put those together, you're going to end up with positive 30x, and then it's going to be minus x squared. Okay, so that right here I just wanted to show is going to, once factored, really become, and I don't know why it won't let me erase that, but it's going to end up becoming plus 30x minus 2x. So it's not letting me shrink that, which is kind of annoying. Okay, so that got a little sloppy, and my apologies. But I just wanted to I realized that I was skipping something, and you were going to maybe be confused at where the positive 30x and the negative x squared came from. So now I can simplify a little bit further. So I can combine those guys, right? And if I do that, I end up simplifying, and I can also deal with my negative x squared on both sides by adding x squared. When I add x squared, that's going to go away. Okay, so what we're going to notice, if you will, is that when I keep going with this, I'm going to end up, and this is going to be a negative, which I can add, I'm going to end up with 130 equals 30x. Sorry, 30x, which then I'll divide by 30, divide by 30. So we know that x is going to be equal to 13 over 3. Okay? And that, again, I know I'm jumping around a little bit, but I don't want to make this video last forever. So from there, oh, that's annoying. I now know this piece. So if I go very back up to my beginning, whoa, that now is probably really confusing. So if I go back up, that was really x. So I now know this is 13 over 3. Okay? So I could do that same process, knowing that, and I can put that 13 over 3 in place of x over here, and I can figure out the whole base, which I already know is 15, but I can use that to figure out the height. So now I need to really go back and plug in my value of x, which I now know, and I can find the height of the triangle. Okay? So if that was frustrating or confusing, my apologies. I'll try to make another video to clarify, but this one will be posted and accessible so you can at least get an idea of kind of the math behind it. But by knowing x, we now know two sides of a right triangle, which will allow us to find the third using the Pythagorean theorem.